All right, it looks like it's 10 on the dot here. We have about just under 30 on the call today. David, I think we'll go ahead and get started if you're ready.
Yeah, ready.
Perfect. Again, I just wanted to say good morning and welcome. We hope everyone had a really nice Memorial Day weekend. Hopefully you enjoyed the weather a bit. So before we get started, we wanted on the call to be aware that you have been muted upon joining today's discussion. Once the discussion gets rolling, you'll have the option to go ahead and unmute yourself if you want to contribute to the discussion. Another option is to utilize the chat feature throughout the call, and we'll monitor that feature for today's discussion as well. So again, to get started, this is the first of 5 discussions focusing around virtual labs in the areas of the sciences. This discussion will stem around the discipline of physics. So at this time, I'll go ahead and pass off the reins to the TAG lead physics lead, David Ingram from Ohio University, to begin the discussion. So David, the floor is all yours.
Thank you, Jessie. Yes, this is David Ingram. I'm the chair of the physics department at Ohio University. I've been the chair of the TAGS panel for physics for a number of years now, and so some of you may have submitted things to us and got them approved and so on. We have been in discussions amongst our own colleagues and across the state and across the nation, seeing what different physicists are thinking about in terms of how to deal with the lab component of our courses. Part of this is driven by the fact we really want to give the students the best experience we can, despite the fact that we are having to deliver some of these things online, and clearly delivering a lab experience online is one of the most challenging. The state has given us some forbearance in this regard for OTM and TAG courses, of which many of the courses that we teach in physics departments are students covered by. And what I hope you can see is the document that broadly outlines what the state expects of OTM compliant natural science courses, of which obviously physics is part. This first page just deals with, I think, more general issues, but as we scroll down and we get to the second page, it's really this guideline 13, which we need to try and follow as best we can in these times. What you see there is that there should be a lab component to all these natural science courses, which involves the realistic measurement of physical quantities, data analysis, realistic interactions with experimental apparatus, synchronous feedback, and effective interaction with the instruction. Clearly that presents some challenges. And so as we go through various things that we're thinking about today, we need to bear in mind that these are some of the guiding principles. And we can see that there are opportunities here to deliver some things online that will meet these requirements, but there'll be others that will be a significant challenge. And we need to think about ways to get around them. For instance, just the simple realistic measurement of physical quantities, that can be a challenge, but I'm going to try and show you a couple of examples where I think we can begin to get around some of these issues online. One of the first things that we thought of in Ohio, when we started thinking about these issues was to think about using some FETs. I'm not sure how many of you are aware of the FETs. I'm going to try and do this now. Show you my web browser. I think it's that one there. So hopefully you can see my web browser now.
Can't quite see it just yet, David. You might need to stop sharing the current document and then
Okay.
share your web browser.
Yeah, let me try again. Did that do it?
Yeah, there you go. Perfect.
Okay, right. So FETs, hopefully a number of you are aware of these things, but FET is spelled P-H-E-T. They originated with the University of Colorado, so a Google search just on those two terms, FET Colorado, should bring up this website, fet.colorado.edu. You can see that they cover more than just physics, but physics was perhaps one of the first ones to get really established there. Click on physics and you should go to a page that has, as you can see, a list of topics over on the left-hand side and a whole list of FETs that are available. Now, one thing I'd point out with these is that they have been slowly converting them away from using Java and Flash to HTML5. And the reason for that is that many students find it difficult to use the Java or the Flash versions, whereas the HTML5 ones should be compliant with all modern browsers. One of the examples that we've been using is under Motion. We've been using the Springs Basics one. So I clicked on that, and you've got two choices. You can download or you can embed. I'm just going to run the thing live on here for you now, because I think we've got a reasonably good connection. But for students that have got difficulties with internet connections, these things are downloadable onto their laptops where they have got a good connection, and then they can run them offline. What you can do with this type of demonstration lab is that you can make some reasonably realistic physical measurements. For instance, you can attach a mass to the end of this, and you can see how it extends. You can change the amount of mass on the end. You can run it in various modes where you can have the spring oscillating and so on. And as I said, you can make measurements on these systems. You've got a timer and so on. So you can do all the standard things that you might want to do in a simple harmonic motion lab. And this was a lab that we actually wrote around this FET for this previous semester. The students, in terms of sort of getting this close to a real lab, have to use the ruler and their best judgment, and the timer, counting things and so on. You've got various options that you can turn on. You can get the acceleration and the velocity vectors shown on here. So it's actually got some features that you can go beyond the lab with if you want to. But I think it's a good example of how these FETs can be used to reproduce some of the labs that we do and still enable us to have the students make measurements that are reasonable. They're going to have errors associated with them. And so it's a reasonably realistic approach to this method of getting these labs online. Another lab that we actually used was, I'm going to just step backwards now In thermodynamics, we used a gas properties lab, and with this one, you can just look under ideal gas conditions. They have various ways of doing some basic thermodynamics. You can inject some particles either with the pump, or you can just do it with the control over here on the right. And you can put in heavy particles, you can put in some light particles, you can observe what goes on. You can change the volume if you want, and you notice the pressure goes up. In the different versions of this particular FET, you can do different experiments, monitoring, demonstrating to students some of the properties that ideal gases have. You can heat and cool the system, so you can add heat and the temperature will go up, or you can cool it down and the temperature goes down, and the particles will move more slowly. There is a write-up that you can download that tells you what the dimensions of this container are, and you can actually do equation of state calculations based on the contents of this system. So I think with the FETs, we've got a good group of experiments that we can build around for doing some of the online activities. It isn't the complete system by any means. What I'm now going to try and do is switch to a different browser that I've got, and yes, you'll have to tell me, can you see this browser now?
We can see it, yep. Okay,
good. Where we are at the moment, we're inside our Long Kappa course management system. And this is a course that's actually running over the summer that my colleague, Mark Lucas, is the instructor for. What he's done is he's prepared some instructions for doing an acceleration due to gravity lab. I'm going to try and get those to pop up now. So we've got a write-up. We see down here a picture of Mark, and if you click on the system there,
I've got a second career as a mime. I'm not going to voice this over. They probably get the idea by now, so you could put me out of my misery here.
Okay. So, yeah, the voice that's been joining us is Mark Lucas. He's actually the person in there. But you can see what you can do. You can have somebody describe the experimental equipment. So they get a feel for what the experiment entails. And then what you can do is you can switch to looking at some data, and for this the students have got these timing marks along the track, and what they have to do is
the first one had a little bit of introduction to it. I'm going to release it shortly and run to the other end. I'll yell when it goes past each mark. but they can also analyze the video itself by getting into somewhere where they can go frame by frame if they want. One of the things we don't do this with this lab is use very precise measurements from Pasco or the like, because part of it is just understanding that there's plenty of error going on in this from the timing itself. And I asked them to use their cell phones as the basic timer if they would like.
And what they have here is a whole set of trials. So we've got multiple trials with a 3/4 inch riser, and then some more with a 1 inch riser. And so this is another way in which you can assemble an experiment and give them the task of making the measurements online. The other thing that we are preparing to do as we move towards fall is to think about how we can bring students back into labs. It's expected that we will have social distancing requirements, and that we may only be able to get half the students in the lab each week. That's just based on what we estimate those physical distancing requirements will be and the size of our labs. This means that half the students will do a real lab 1 week. The other half will do a dry lab or an online lab. And then the following week, the students will switch, and the other group will do the live lab. Trying to figure out ways to get these students to collaborate, as they normally do in pairs or in groups of up to 4 sometimes for some of the experiments, is going to be a major challenge. But that's going to be a challenge that all of us face with the online components that we're going to be having to deal with for the courses in the fall. One of the other things that I particularly wanted Mark to talk about is some of the apps that he's been discovering that are potential sources of ways of developing labs, although we haven't done anything in great detail. So Mark, I don't know if you want to just try and describe some of those to us.
Okay, well, those of you who are members of AAPT and get the physics teacher probably have seen a lot of cell phone articles going by. It's well known that your cell, so we're talking accelerometers and light sensors and compasses. Even I had a cell phone that unfortunately died on me, but it had a barometric pressure measurement device in it. And so using these accelerometers, you can do a number of experiments. There are a bunch online. There are lots of free apps. We have focused on one app called Phyphox from a university over in Europe, Phyphox. Again, free, and it will do graphs of quantities versus time. It will create spreadsheets that you can download. We have not explored as much the Google Science Notebook, but that is another option that is available both on iOS and on Android, where again you can use the sensors on your lab on your phone. And lastly, AAPT has there are a lot of articles out there on using cell phones in different ways. The only thing you have to do is make sure you protect your cell phone during the experiments. But that is one set of options that we'd like to look at. And I'd like to, I don't know whether you're intending to mention this, David, but I know that Gabriella has done a lot of work with video analysis of data. So, for example, those AirTrack experiments that I was doing, you could place into video analysis software from Vernier or from Pasco. As well, there's an open source program called Tracker that's been around for a while. And you can lay down a coordinate system, record the location at different points in time. You can track the object and do some of your motion experiments that way.
Okay, thank you, Mark. Jesse, do you want to? How do you want to run the rest of this session?
Yeah, so thank you very much. I know we have some questions in the chat feature right now, but I think we wanted to take a moment again and thank OU for sharing some of their examples of how they're kind of dealing with virtual labs this past spring semester and work that they're thinking about this summer and fall. It sounds like maybe a mixture of both the lab and thinking about some in-person labs this fall semester. So with that in mind, I just wanted to open it up. How's your institution dealing with the virtual lab component? Maybe what are you doing on your campuses this spring and this past spring semester and upcoming fall and summer semesters? You're welcome to put that into the chat feature or unmute yourself and kind of have some open dialogue here. It looks like we have about 42 on the call here. So again, what are you doing on your campuses? How are you dealing with the virtual lab component, maybe in the past spring semester, this upcoming summer and fall semesters? Might be too early, huh? On a Tuesday morning.
I'll jump in. This is Jason Dybel. I'm chair of the physics department at Wright State University. And for the spring, it was the Mad Dash. What we did was recordings and provided sample data. But what we've done for this summer is one that it's we're doing synchronous labs that the students have to log into a session with their graduate teaching assistant, and they receive the sort of same instruction, and coaching that they would receive, if we were doing things face to face. Excuse me. And then what we had hoped was, at least for like in the mechanics-based labs, was to use PHY, the PHY Box app. And what we found on that was our lab instructor coordinates all of our labs. Just in a sampling of our graduate teaching assistants, we found several phones that did not have the necessary gyroscope components. So we have fallen back from that and using a combination of simulations and asking students to provide materials to do some experiments. We're hoping that we can utilize that more. I've looked into some of these boxes, these kit systems from, like Carolina Labs, hands-on learning, things like that. And at this point, I'm hesitant to do it just because we're mindful of costs. We switched to OpenStax for our physics curriculum this year, just to try to, drive down student costs. And with the economic implications of COVID-19, I'm really hesitant to add a $100 box of components I don't have complete faith in just yet. So we're trying to think about what we're going to do for fall. It's a little bit more robust. At this point, we don't have, like most institutions in the state of Ohio, I don't think we have any guidance yet. Firm guidance is what the fall is going to be like. So I'm planning for everything under the sun. And that includes an emphasis on remote, I think, at least partial. And we're going to think about some other ways to do this. I wish the cell phone thing would have worked out better, but it's that thing we run into with remote instruction of being able to count on students having access to this technology, and that's not always the case. So I'll unmute myself. If anybody has any questions, I can answer in the chat.
Thank you, Jason. I can answer a question that's popped up in the chat from Anna. Are there any requirements from ODHE about physics students needing to be in person this fall, or can institutions move all physics labs entirely online? The TAGS panel chairs met to discuss this, and the consensus is that we can use roughly the same requirements as we did in spring, in that we would like students to get as much lab experience as they can in person, but we are not, the state isn't requiring the full requirement of in-person labs. However, we do want to try and make them as much as we can, as close as we can to those in-person requirements. Paula, I don't know if you want to step in and make any other comments on the what the state is expecting from us, in particularly for the OTM courses.
Did I hear you say Paula or Paul?
Paula.
Oh, Paul. Okay, I heard it then. Correct. Well, first of all, I'm so impressed that 40 of you are participating in the call today. And David, thank you, and all the people who are sharing. Um, I think our goal is to make sure, as we all want as the students, to have the best learning experience that they can have, and knowing that you would prefer to have, in-person labs, and that might not be the case this fall. So what has happened that I really want to applaud the OTM leads, as well as the OTM, the TAG leads, as well as the OTM Natural Sciences Committee, that they were saying they understood that in some cases that we would need to continue with the virtual labs. And that's why we are having these sessions now, for people to communicate and help with one another. The one area which people were concerned about is organic chemistry, and that conversation is going to be later on in this week. For safety reasons, they felt that they couldn't necessarily teach students organic chemistry without an in-person experience to a certain extent. So they're looking at ways that they can maybe adjust their curriculum, that type of thing. So the whole idea this fall is that we know that, again, we will accept the virtual lab experience with the idea that hopefully down the road we can get back to where we were. However, people need to help each other and go from there. I don't know if that answers all your questions.
I think that's a good explanation as to what we're trying to do with all this, Paula. By the way, if people didn't recognize, that was Paula Compton. She's the Vice Chancellor for transfers.
So I have the pleasure of working with all of you. And also, like I said, I applaud our faculty every single day. What you're doing is wonderful and very much appreciated. In fact, we were having a meeting last week, and people were saying they have come to realize that professors and teachers rock, that you're doing such a good job in helping students. So, but we know it's not easy. And that's why these kinds of discussions are really helpful. And one of the things that we want to find out from you is if you know of someone in the United States that's doing something really outstanding in this area, if it's something that we can help to arrange for that individual or individuals to do a presentation for all of you, we would take it from here. Not that you're not doing a great job, but you know how in a profession sometimes people go out and do something and we go, I'd like to learn more about that. So we want to be here to help to facilitate and support you, facilitate discussion and support you. You are the expert. So I hope you can continue talking with one another about what's been hard, what surprised you in terms of going better than expected, because I'm sure it's hard being by yourself on a campus or even with your small group on a campus.
Thank you, Paula. I got another question that sort of fits in with this from Dean. Are there specific guidelines about what requirements are relaxed during the current crisis? The last couple, and I think he's referring to the guidelines in guideline 13D and E in the document I pulled up originally. It talks about synchronous feedback and effective interaction. This is where I think we need to figure out ways going forward. And this applies to many of us who have classes where the students are working in groups normally. We have to work a lot harder, I think, at getting some of the Zoom breakout rooms or the Teams channels to work so that the students are able to work together. The synchronous feedback piece, that's where there are real challenges, particularly over safety, and that was where Paula was addressing a concern that came from organic chemistry about that. Effective interaction with the instructor. We have tried to have TAs available during particular times with online labs. I think we're going to have to be a little bit more forceful and require students to take part in some of these activities. this is going to require again more work on our part to figure out ways to induce them to work together, to provide them with questions that they can ask each other about a lab or a particular activity. There was a good article yesterday in Physics Today that addressed many of these issues broadly around the teaching of physics online, but this was seen as one of the big obstacles in trying to get students online who originally didn't sign up for an online course. And that's true about the courses we're delivering over summer and on into fall. These students don't really want to be in an online class. They want an in-person class. And so particularly with some of these larger classes where we're going to have to probably teach them online in the fall, we're going to have to work out ways to get these students working together. Even if they are allowed back on campus, the chances are they're not going to be allowed into a large, densely populated lecture theatre or into a lab where we will have as many as we normally have inside those labs. And so that's one area where working together, I think we're going to have to come up with some good ideas as to how we get the students to interact. Are there other questions and comments?
I saw the comment there. This is Paula again, that a one-day virtual conference where people share examples of lab will be useful to learn from each other. Would you all be willing to share that like OU did? And would you be like, would that happen over the summer? Are you all going to be available? Could you provide more information on that? I think that was Gabrielle. I don't, maybe, or others can chime in.
Well, I can see that Jason has said that he'd be interested in doing that. And I think once Mark has finished teaching in his first half of the summer, I think we at OU will be interested in doing some of that, because Mark will be one of the people that I'd like to include in that.
David, you mentioned some guidelines. I am the Associate Dean of STEM at Cuyahoga Community College in Cleveland. Where are these guidelines, where are the guidelines posted? I'm not a physicist. I am just
okay.
as the Associate Dean that heads 5 different disciplines.
Jesse, Jesse could give you the website. We have it on the,
Yeah.
she'll post it for you.
Excellent.
Yeah, I was gonna say it's on our website, and I'll go ahead and put that in the chat here, just as reference for all on the call.
Okay.
I'm seeing, yes, I would be interested, would be for people to create short, let me see, at Miami, we have confirmed plans we can share later what we're doing. So if we did this over the summer, there would be interest if we did this, right?
I think so, yep. It looks like July might be a good time to try and do this.
I think what would be helpful is if you would send to David or to me or Jesse your interest in participating in this, and if you're willing to share something, because it would just, we can put this together very quickly if we, number one, know your interest, and number two, if we know that you would be willing to share what you've created, that we could make that happen. David, do you want to go ahead and put your maybe I should put my email address, and Jesse, so you would know to write to us. That would just save us from having to go out and find it. Jesse, can you put yours in? For some reason, I can't get mine to go in the chat.
Yes, I went ahead and looks like David went ahead and sent his email, and then both yours and I, Paula, are now within the chat feature. So again, those on the call, feel free to reach out to either one of us.
And we could, you know, put this together for you. And if you want to participate, something to share, or if you know of people that you, like David said, he already knows somebody that he wants to have part of this. I guess what I want to learn more about is, what is your biggest challenge? Your biggest challenge with all this?
If this is David Ingram, I'm going to say that my biggest challenge is just working out how we deal with the social distancing requirements. We went through an exercise at Ohio University where we identified courses that were critical for fall. So these are required classes for various students. And then said, well, can we do these face-to-face? And we decided we probably can't do some of the service classes face-to-face. And so that now presents the challenge of how are we going to do these classes? As I said, one of my biggest challenges in doing the calculus physics course online is getting students to talk to each other online and talk to me online. Because they are very reluctant, it seems to me, to do that. That's one area that if people have got figured out a good way of getting either Zoom or Teams or some other group management system together, that's something else that we could include in this exercise in July.
I've been reading back through some of the chats, and perhaps Ryan could talk about Pearson's information that they had and what they liked. What did you like about that, Ryan? Okay.
It looks like you're still muted, Ryan. Oops.
I was just interested in knowing what they had, because we could, and then I think also somebody indicated at UC Blue Ash that they had an interesting experience. If that person, oh, that was also Dean, I think. That was Dean. I saw him chatting, but maybe he can't hear me.
Now, this is Dean Stocker at UC Blue Ash. Mm-hmm. And if I can share my screen, I can just show you. Hopefully you can see that. This is the Pivot Interactives page that we used. This is from Vernier. So they've got a lot of different videos. If you go into any of these, they've got multiple different videos you can watch. You can change parameters, and then there are video analysis tools like protractors. And so we took the labs that we normally do and sort of rewrote them, modified them so that students could take data through Pivot Interactives. And we like that because it looks more like using real instruments rather than just using a simulation.
Dean, do you have a cost estimate for what it would cost for the students or the university to provide this?
We had there was a 30-day free trial, so that's what we used.
I looked.
Gallagher's on here too. Joe Gallagher took his first 30-day free trial, and his was expired by January.
It is $10 per student for a 6-month trial. I looked it up a little while ago. So $10 per student can be paid either by a university or it can be paid paid by the student. If it's high school, then it is $5 for a 12-month subscription. I wanted to ask Bowling Green how much the students. I looked up the IO Labs stuff because we have dabbled in that, and that was about $200 for a pack from Macmillan for the device itself. Is that the right estimate for the cost for the lab? Bowling Green.
This is Andy Layden from Bowling Green. I personally haven't used the IO Lab device, but one of our online teachers has. Actually, 2 of them have. And I think just recently they changed their model so that they're now offering rentals that are more affordable. I would guess it's $60 for a semester to rent the device and then return it. I'm not quite positive on the exact number, but it's of that order.
Okay.
So a bit more expensive certainly than the Pivot Interactives purchase, but the advantage there is it's a small physical device where you can perform physical experiments, hands-on experiments, and measure forces and a variety of things, light intensities. I think it can even be with some adapter kits to electromagnetic, electronics circuits, things like that.
Right. Matt has done a great job designing that. It's basically an everything device and can do a lot if you're careful with it. Yeah.
And it is breakable, so it brings some element of lab safety. I can look up a reference if people are unfamiliar with it, and I'll try to post that a little bit later on the chat.
Thank you, Andrew.
Thank you.
You're welcome.
There's
These companies that are offering these services, do you feel good about those, or they're new at it, or what? I don't know how we could do that, but are you seeking them out, or are they seeking you out on all this?
This is Andy again. I'm not sure quite how to reply to that because I was not the instigator. One of our online professors sort of got involved with IO Lab devices, I think 3 or 4 years ago, and kind of brought it to our communal attention. Great, there's a link showing up for the IO Lab device. I think it was probably through this sort of, show and tell type interaction that we first learned about it. And so, again, it adds the value of this sort of activity to just make us all aware of all the options, the vast number of options that are out there right now.
A lot of this has been very standard at AAPT meetings the last few summers. I know that in the Cincinnati meeting a couple of summers ago, Matt had a very large display of different experiments that people have put together with IO Labs. The FETs are sort of industry standard. So I am presuming everybody here knows that aapt.org is a place to head to for resources. I just haven't had enough time to breathe to go check out what kind of stuff is there. But a lot of these things have been around for a while and are pretty standard. It's more the video labs and the newer produced stuff that hasn't been around quite as long.
There's a theme developing in the chat about exams, and so I think what I'd like to do for maybe the last few minutes of this is just talk about our experience with exams at a higher university and see what other people are experiencing. When we switched to online exams in spring, we gave the students a practice at doing an exam online because we wanted in the calculus course for them to be able to upload materials and get used to a slightly different format to some of the questions. Because we're using Long Kappa, we're able to randomize numbers within exams, just like we can with our homework. And that appeared to be a fairly effective way to suppress cheating. I won't say it was perfect, but by giving the students a fixed window in which they had to do the exam in that was longer than the period of time that they had to do the exam for. So we gave them a 4-hour window for a 90-minute exam. And as long as they logged in before, sooner than 90 minutes before the end of that 4-hour period, then they could complete the exam on time. We did have probably about a third of the students have difficulties with the upload feature, and they finished up emailing photographs of their work to us. I'm a chair of a department, so I'm a member of the Midwest Physics Chairs group. I know several of you probably are. There was a chat going on in there, theme going on in there about exams and the amount of cheating that some people were experiencing with their exams, and that these questions were appearing in Chegg within 30 minutes of the exam starting. I did ask if anyone was using proctoring. Nobody responded yes. We are considering using proctoring during the summer. We'll see how that goes. And that'll really advise us as to what we're going to do in the fall in terms of proctoring of online exams.
Ask me in 2 weeks.
Yeah.
At Ohio University, we have ProctorTrack, and they have broken down and said that the university will pay the $5 per test for the students through summer, as they did in spring. And ProctorTrack basically requires a laptop with Windows or Mac OS. That's going to be one challenge. No Chromebooks, no Linux laptops. Must have a webcam. I just had a student contact me today that he can buy a webcam for $100 and use it twice, and that there, some places are saying it's 2 months before you'll get stuff. But ProctorTrack will basically identify the student, watch the student over video. Anything that it deems is an infraction by the AI, it will record a screenshot of their screen, and it will sort of allow you to then decide whether there were true infractions or not. Students have to onboard, giving the proctoring system a chance to learn to identify it and get good pictures, things like that. What we're going to do is it's integrated with Blackboard for us, but I'm going to go through a Blackboard exam and then run off to Long Kappa. We have a way to do that, and the students again will be given a 4-hour time window for a 2-hour exam, so that they have a little bit of flexibility getting in and getting out. And so we'll see what happens there. I know that my colleagues at the branch campuses, the regional campuses, have been using Zoom because their numbers are low enough that they can basically get their 15 or 20 kids all up on Zoom with camera and screen, and then they just run around and proctor themselves, which may be something that I need to learn a little bit more about here in the future. So that's what I'm trying to do this semester.
Do people want to share some of their experiences with online exams or their thoughts? I don't know anything about Respondus.
Yeah, David, it's Jason again. We use that Respondus lockdown. Sounds very similar to ProctorTrack, and it's what our university has. And not many faculty used it. I did have one that we have an undergraduate learning assistant program, and we did everything we could to keep them employed. And one of the things that we had them do was go through, because if the software doesn't red flag anything, we found there's still some things that can slip by. And so what we did is we actually had the LAs skim the videos and see if there was any inconsistencies to red flag for the instructor on record. And see if there was anything there that proved pretty time consuming. We didn't see anything like that at all. And we didn't see any blips with the exam score. So Respondus is another one out there that integrates with learning management software systems. But I think one of the biggest things with this too is just that and maybe it will be better in the fall. We have time to prep, and it's been a little bit better this summer. It's just the rapid learning curve a lot of faculty had to have with this. Turning on half the features of learning management systems that we had never used, things like that. But Respondus is another one that's out there. There's a couple of other ones. I ask because just even the format of how you deal with the test and stuff like that. And ProctorTrack sounds great, except for that issue of requiring the laptop with the webcam. I mean, we're still having lots of students who are doing everything through a phone. And our university was pretty good about trying to get them laptops. So I don't know how long that's going to be sustainable, especially when we get into fall. I'll mute now.
Yeah, that's a concern that I know we've had from not just the accessibility of cameras, but the fact that there are some students with either limited hardware or limited internet in our region, and I don't know if other people are experiencing this as how big a concern it is. It seems to be a concern. We certainly have had students during exams that have contacted us because of internet issues, and we've had to give extensions and so on, or reschedule exams. But it's a small number of students that are experiencing these things.
I think there's about 9 more minutes left on the call. I don't know if there's any other feedback from individuals participating today on what's working, what's not working, what you're using for assessment or exams. It sounds like potential follow-up this mid-July. I've already been receiving a few emails, so that's wonderful. Again, feel free to reach out to us if you have interest with your institution in participating in that. Again, I guess last final call before at least this portion of the physics discussion ends. If anyone has any additional thoughts or clarifications they might want to know about what's kind of being taught virtually across the state.
I don't have any comment. Just want to thank you guys this is the first time I've gotten involved statewide to hear what's going on. We are in Cleveland, so you feel pretty isolated sometimes and away from everyone else. So I thank you for putting this session together. It's been informative for me.
You're welcome.
I want to thank David and everyone who participated today. I was just wondering, do you want one day, or would it be easier just to do something in smaller blocks that we would send out to you all? I don't see any comments. We could work on that. I just wondered, sometimes it's hard for people to give, a period of time. Whatever is easiest oh, how nice is that? Joseph said, I vote for one day, but record the sessions. Okay, I got it. All righty, that's helpful. Well, we'll work with David, and I already got some volunteers to help us, and we'll kind of go from there. I still think one thing that David indicated, and I think it's a challenge for me, even in my job as an administrator, is getting people to talk. We're so used to seeing people face to face, and you can look at somebody and then they'll respond to you sometimes. But when you're doing something virtual, sometimes it's really hard to get that conversation going. But I have found that once you find something that they're all really interested in and they can relate to, sometimes people will really open up, kind of like you've all done. But that is hard to get people to kind of engage. And plus, people I think are so respectful of one another doing these WebExes. But that might be something, if any of you know the secret to that, that would be helpful.
It's definitely something that I'm going to be working on over the summer, trying to figure out ways to get the students talking to each other and to me.
Maybe that's something we can research and see if, like for example, we saw a presentation maybe a month ago that someone put on how to run virtual meetings. And it was so helpful for me because one of the things that I learned, they said after 50 minutes to an hour, you need a brain break. And I didn't know what that meant. And it meant just taking 3 or 4 minutes to stand up and stretch, because it's so hard to be engaged in a long-term meeting or discussion without that break. And so we've been trying to do that in our meetings, and it really does make a difference. People just need that because people are conscientious. Using Zoom rooms, okay. But anyway, I'll see if there's somebody out there. We have EAB that we're part of, Education Advisory Board, and I can ask that question if they have anything on how to keep students engaged in discussions. I will research that, David, and see if they have anything for us.
I think that would be good, because this isn't just confined to physics. I think all the science disciplines would appreciate this, because we have many students who are in these classes because they're required to be in them. And so getting them engaged is always a challenge to us. And just moving things online has made that challenge so much greater.
Well, I'll send that up the flagpole. EAB, if you're not familiar with them, they're a research group. And they really, and we have a membership, and I think they would find that to be interesting. Let me see what I can't promise you anything, but I can raise the question.
Okay, good, thank you.
Well, thank you all. Jesse, do you have anything more?
No, I was just going to say thank you. I think it was great discussions, and thank you for participating this morning. And we look forward to, I guess, talking and speaking with you in the future. Thank you.
All right. Thank you.
Bye-bye. Bye-bye.
Bye.
Bye.